I'm standing in front of Science on a Sphere. This is something that I invented for the purposes of science and education. A little bit about how it works. It's simply 4 projectors around a spherical projection screen, the first spherical projection screen that was ever used this way. What we like to do is display things like the Earth. And we can display anything on the Earth. We can display the clouds, the oceans, the life, the geology. So it's a wonderful way to look at science, both for scientists and for the public. And those are the 2 applications. Scientists really need to understand the Earth as it really is, or the sun as it really is. And the public does too. The public is faced with very difficult issues, such as, what about climate change? What's going to happen? They can understand it better when they are able to see the Earth the way it really looks and to see the changes that scientists anticipate happening. You know, if you're ever an astronaut, this is how the Earth is going to look. The kids love it.
Okay, good afternoon. This is our 2:30 Science on a Sphere. My name is Jeff from the Education Department. You're on vacation. You will not be tested, but you're going to get questions. Good luck. We will start. This is where you and I will, by the way, this is not levitating in midair. It's being hung by 3 thin wires at the top. This is nothing more than a carbon fiber screen. There's a projector every 90 degrees. And those projectors are controlled by the computer over there in the corner, and I'm controlling it from the iPad. And that's what this is all about. All right, this is where you and I live. This is the Milky Way. Up until about, it's a galaxy. And up until about 100 years ago, scientists thought this was the entire universe. Well, last year, NASA announced there are 2 trillion galaxies. That's with a T. And each of those galaxies hold billions of stars. So scientists tell us today there are more stars in the universe than all the individual grains of sand on all the beaches on planet Earth. The closest star to our solar system is Alpha Centauri. For the folks on my right, you can see it. For the folks in the cheap seats on my left, now you can see it. And so Alpha Centauri is mostly visible in the southern hemisphere. It's actually made up of 3 stars. Now, one of the ways they measure distances in astronomy is light years. How long does it take a beam of light to travel 1 year? So, this is the closest one to our solar system. And here's your first question of the day. Alpha Centauri is only 4.2 light years away. Is that close? Yes or no? All together now, yes or no? Yes. Okay, a few people said yes. Let's try to convince them otherwise. Next door to us, thank you. Thanks. Thank you. Thank you. Okay, I get the radio back. All right, so next door to us is Space Shuttle Atlantis. Hope you all saw it. When it was flying around the Earth, it was going 5 miles per second. So that means if you drove, to get you back to Orlando, it only take you 10 seconds. So if you were able to get aboard the Space Shuttle Atlantis and fly to Alpha Centauri, it would only take you 165,000 years. Is Alpha Centauri close? No. A little bit closer to our home. The closest star to us, Earth, is the sun. Big thermonuclear explosion. And now the clouds are breaking up. You can see the sun for the first time in about 3 or 4 days. Thank you. And so when you walk outside and that light hits your eyes, the light left there 8 minutes ago. Because the sun is only 93 million miles away. So NASA, that you're visiting today, has visited every planet in our solar system. This summer, 2018, this summer, NASA is going to send a probe to the sun. No volunteers for that mission. Why are they sending a probe to the sun? because the surface of the sun is only about 10,000 degrees. But when you look outside and see that orange yellow, that's the corona. And it's 1 million degrees. So they're trying to find out why is it so much hotter away from the surface of the sun. So they're going to send this probe, not going into the sun, but you have to go in and out of the corona. So how do you protect that probe from that 1 million degrees? Two things. It's going to have one side of it always facing the sun, using the same materials that they use to protect the space shuttle during re-entry. And the other way to protect it, and to keep it from falling or going into the sun, is speed. So remember, the space shuttle used to go around the Earth 5 miles per second. How fast is this probe going to be going? 120 miles per second. That's from here to Busch Gardens in Tampa in 1 second. And that's what NASA does. It does the impossible. Any guesses what this might be? Okay, the young man back here said Mercury. For the first time in 6 months, somebody got it right. Because most people yell out the moon. Mercury. It's the closest planet to the sun. You might think, well, it's so close, it must be the hottest. No, it's number 2. How do they know that? Well, it's about 800 degrees on that surface. But up until a couple of years ago, NASA had a spacecraft orbiting around this planet. And much to the surprise, the scientists, they discovered ice in the North Pole and ice in the South Pole. So they don't know how the ice got there, but the reason why it exists, because the poles are always in shadow. The hottest planet in the solar system is Venus, the Roman god of beauty and love, because she's so hot. So Venus is covered with a thick sulfuric acid clouds, like wearing a fur coat in Orlando in the middle of July. A big greenhouse effect. So we're talking about temperatures about 900 degrees Fahrenheit. And yes, Russia has landed spacecraft on that planet, but it didn't last for very long. Not so much because of the heat, but because of the pressure. So not a great place to visit. Hot, sulfuric acid, and high pressure. So about 2 decades ago, NASA had a spacecraft orbiting around this planet. You can't see the surface because of all the clouds.
Our global civilization is shining brightly out into the night. A question for us is, what is the impact of the large energy use that humans have? This is something that we need to understand scientifically and that the people of Earth need to understand. Here we're looking at the Earth, and what appears to be bees flying over the Earth are actually commercial aircraft. Each little yellow element is a commercial aircraft, and we've gone through an entire day of air traffic. What we see is that as the sun rises, the continents fill up with these little bees, and as the day goes on, you see great streams of aircraft going from continent to continent across the Atlantic and across the Pacific. We're looking at the Sea-Wift satellite. Through time, through the seasons, we can see the northern hemisphere as the leaves die in the fall and the trees drop their leaves. It becomes barren, it becomes snow-covered. But as the summer wears on, we see this tremendous explosion of biology. And that biology is not limited to land. The leaves on the land are one thing, but we also, in the Sea-Wift satellite, which is really sensitive to photosynthesis, we're seeing that the ocean, the phytoplankton, change with time too. And in fact, as we look at it, we see actually the deserts of the ocean are right up against the deserts on land, and the areas that are really a riot of life in the ocean are right adjacent to the areas in the higher latitudes that are very densely covered with trees and vegetation. So you have the ring of ice, the ring of life, and the ring of deserts. And finally, around the equator, another ring of life. Life on this planet is the distinguishing characteristic. We don't know of any other life elsewhere, and one of the things we want to do with our science is really understand life and protect its future on the planet.